Hello everyone, my name is Peter Brunt from AVR Optics. Today I'm going to be talking to you about Argolight's game-changing microscope calibration slides. In this 5-minute presentation, I'm not only going to be telling you about how these slides work, but I'm going to be taking you through the workflow to show you how simple these slides are to use. To begin with, Argolight slides come in several models, ranging from the low magnification LM to the high magnification HM and the SIM for structural illumination. Each of these is also available in a power version, which includes a fully calibrated power meter for measuring excitation power. So how do these slides work? I think when most microscopists think about a calibration slide, they're probably thinking about a slide with fluorescent microbeads, or perhaps a flat fluorescent slide with no structure at all. These options serve some purpose, but they're either not repeatable or offer limited information. In contrast, Argolight's Argoglass technology allows them to create stable patterns of inorganic fluorescence that is extremely precise both in structure and in fluorescence output. This means we can look beyond point spread functions to explore what is really going on with our microscopes. For example, in numbers, how good is my field uniformity, or how precise are my z-stacks? Each slide comes with a series of patterns for running these tests and many more. Let's take a look now and see how these slides work. Here I have loaded the Daybook 3 software, and one thing that's really important to understand about Argolight slides is that you're not paying for just the hardware, because the software, while free to use for performing analysis, makes up a big part of the overall solution. The slide will allow you to take the image, but the software drives the analysis. When performing a test, it all starts with an image. In this case, we're going to be using Field of Rings pattern, which features on all Argolight slides. This image should be taken like any other fluorescence image and ideally be saved in the standard format for your software. Most microscope image formats are accepted, but when in doubt, save it as a .tiff file. The reason for this is that we want that metadata. If we can't get it, then supporting information can be entered manually, but having the metadata saves time. Once you have your image, use the Upload File button to load it into Daybook. You can also use the File Watcher to automatically load files saved to a particular folder. As you can see, I already have my image, so now we're going to go ahead and select our test. Today, I'm looking at field uniformity, and as you can see, we're pulling some of the required information for the test directly from the metadata. Provided we have this, we can go ahead and start analysis. On this page, you'll have the opportunity to crop the image if needed, and we provide guidance on what that should look like. In our case, our image is the right size already, so we can go ahead and click Run. Some analysis will take longer than others, but field uniformity is a relatively simple one, and in just a few seconds we'll have our result. The results page will show a variety of different metrics, depending on the test, and as a physicist, one of the things I really enjoy about this solution is that Argolight are 100% open about how they define their metrics. In the help section, you can find guides on every type of test that describes these things in detail. For field uniformity, you can see that we're presented with a heat map in addition to line profiles based on the diagonal axis and the max to min vector. From personal experience running demos with these slides, I found that this level of difference is more common than I'd originally expected. We'll also be given a number of primary and secondary metrics. And all of these can be exported as either a generated PDF report or as raw data. And finally, if you upgrade to the paid version of the software, you'll have access to Data Manager, which will allow you to create a profile for your microscope and to store each test on a timeline so that you can monitor long-term performance, allowing you to not only make sure that your microscope is performing, but to spot changes in performance before they become an issue. That's it from me. Thanks very much for your time, and if you have any questions or would like to learn more, please come talk to us or do get in touch.